Hi guys, I just went and got this can filled with gasoline. I can't get my car started. I don't know what the problem is. It's sitting out by the road. I went out a while ago, tried to start it, it wouldn't start. Now I'm not super mechanical, but I tried the basics. I tried changing the oil, didn't work. Tried changing the spark plugs, still won't start. So I thought, well, maybe it's out of gas. So I went and got this can of gas. I'm gonna try putting gas in it. Well, here, let me show you. The car is sitting right out here on the street. I'll hold this up to the window and let you see it. Yeah. So I wish I just knew more about cars. Then maybe I could figure out what's wrong with it. I don't know. So yeah, I'll try putting some gas in it. If that doesn't work, I don't know. I might try changing the air in the tires. Maybe that'll get it started. Anyway, wish me luck. We're going to use this Number Pieces app to try to understand what's going on when we do the standard algorithm. So I'm going to start out by just writing a problem. I'm going to write 17 times 22. 17 times 22, and I'm actually going to cover that up, but 17 times 22. So I've got to make an array right now, and that array needs to be 17 this way and 22 this way. So I'll start with one of these, and then I'm going to make it smaller, so it's going to shrink the whole screen down. 17 times 22. So there I've got 10 by 10. I'm going to make it 11 by 10, 12, 13, 14, 15, 16, 17. So now I've got 17 by 10. I need to make it 17 by 22. So I'm going to add another 10 by 10 and put more these 7 tens in down here. Now I've got 17 by 20. I need 17 by 22, so I've got to add a couple more tens. And then you're going to see, I'm not going to be able to fill this in using these tens, so I'll get rid of that, and I'm going to use ones. Okay, there we have 17 by 22. I think I'll even write that in. And I'm going to get rid of this for now. So we've got 17 by 22. Now our standard algorithm looks like this. Okay, so let's take a look at what we've got. So right here we have this little section. That's like the ones. Those are all ones. And then we've got this section, and this is actually a 10 by 2, so it's ones and tens. Then we've got this section, and that's tens and ones also. We've got 7 ones and 2 tens. And then we've got tens. We've got 1 10 by 2 tens on this section. So I'm going to write some stuff in on these. In here, in this big section, we've got, I better change that color. We've got 10 by 20, which is, of course, 200. And down in this lower green section, we've got 7 by 20, which is 140. And then in this section, we have 2 by 10, which is, that's a funny looking 10. 2 by 10,
which is 20. And then we've got a 2 by 7, which is 14. Okay, now if we look at our standard algorithm, I've kind of written over it a little bit, but what we see is this. We start out by going 2 times 7. 2 ones times 7 ones. There it is, right there. And then we go 2 ones times 1 10. There it is, right there. And then we go 2 tens times 1 by 7 ones. There it is, right there. 2 tens by 7 ones. And then, and I know this is getting messy, we do 2 tens times 1 10, and that's what we have right here, 2 tens times 1 10. So when we do this cross-multiplying thing on the standard algorithm, that's what we're doing. We're just doing all the different sections of the array. Okay, the way this is going to look on your practice today is like this. See, we've got understanding the standard algorithm, and we've got this thing right here, and you'll notice it's what we would call a skeleton array. It just kind of gives us the outside and the dimensions, but it doesn't actually show all the little, squares inside. So that's okay. We actually don't need those. We can see that it's 36 this direction, and we can see that it's 46 that direction. 46. I'm not going to leave those there, but I just want to illustrate that. We've got 40 here plus another 6, that makes 46. 30 here plus another 6, that makes 36. Let me get that mess out of the way, though, because that's not going to be helpful when we're doing other things. All right, so you're going to break it down by section. So first, we have section A. That's where we will start. So section A, that looks like that is a 6 by 6 section. I can see it's 6 this way, and it's 6 this way. So up here under A, I'm going to write 6 by 6, or 6 times 6. And of course, I know that 6 times 6 is 36. And then I'm going to do section B. Section B is right here. And section B is 6 this way, and it's 4 tens this way, or in other words, 40. And so it's going to be 6 by 40. So I'll write 6 by 40. 6 times 40. Well, I know 6 times 4 is 24. Got an extra 0 there, so I'll make it 240. On to section C. I see that section C is 6 this way, and it looks like it's 3 tens, or 30, up and down. So it's 6 times 30. 6 times 30. And 6 times 3 is 18, so I've got the extra 0 on the 30, so that'll become 180. And then finally, we'll multiply the tens area. So we've got 30 by 40. 3 tens by 4 tens. 30 by 40. And so I'll write 30 by 40. 3 times 4 is 12, but I've got a couple extra zeros there. 30 times 40 is 1,200, or 1,200. And now all I have to do is add these together. So I'll take 1,200 plus 180, that's 1,380, plus another 240, 1,380, 1,480, 1,580, 1,620. 1,620 plus another 36 would take me up to 1,656. There's our answer. So the answer is 1,656. So 46 times 36 is 1,656. Now the questions down below, it says, number 1, can you find the numbers we got by using the sketch and the 4 partial products method in the standard algorithm? Can you find those in the standard algorithm? Where are they? I'm going to show you. might not even understand what they're asking. So the first thing is this: can we find where we multiplied the 6 times the 6, just like we do in the standard algorithm? Well, yeah, we can. It's right here, right there. And can we find where we multiplied the 6 by the 4 in the standard algorithm? Yeah, we can. 6 times 4, that was right here, that section. And then can we find where we multiplied, let me get some of this out of the way. Can we find where we multiplied the 3 by the 6 like we do in the standard algorithm? Well, 3 by 6 is right here, this section. That's the 3. It's actually 30 times 6, not 3 times 6. And then can we find where we multiplied the 3 by the 4? In other words, the 30 by the 40. Well, yeah, that's right here, that section. So all 4 of those sections are there. So when we do the standard algorithm, we're actually just finding the different sections of the array, and that's it. Coming down here, it says, what are some things you need to pay attention to when you use the standard multiplication algorithm? What I would think about is this. Does this represent 4, or does that represent 4 tens, or 40? Likewise, does this represent 3, or does it represent 3 tens, or 30? That's the kind of thing that you need to think about, be aware of. Okay, so down below, you're going to do some on your own. So what you'll end up doing, on the first one, they've done part of the work for you. So A is an 8 by 3, right here. A, I guess I'm not writing. A is an 8 by 3. So you have to put in, what is 8 by 3? What is 8 times 3? And you'll do each of the partial products and then the total. And then over here, you'll go ahead and do it the standard algorithm way. Make your paper as big as you can so you can really write the numbers neatly inside the box, like that. When you're finished, take a look at the correcting sheet, the answer sheet, and score your paper.